If you look under the hood of $1 billion tech startup today, you probably won't find millions of lines of custom forged code.
Right.
You're going to find, well, digital duct tape.
Yeah, pretty much.
Today we're exploring why the absolute most powerful skill in modern Python programming isn't actually writing code from scratch. It's strategically borrowing it.
Oh, absolutely.
So welcome to the deep dive. Our mission today is unpacking the secret architecture that makes Python one of the most dominant programming languages in the world. And we're basing this on a set of notes from an introductory course on Python libraries.
Right.
And spoiler alert for you listening, it has very little to do with actual syntax.
Yeah.
It has basically everything to do with the ecosystem, right?
It really does. I mean, knowledge is just most valuable when it's applied.
Yeah.
And the ultimate application of that principle is leveraging the collective intelligence of, millions of other developers.
Yeah. Why do the work twice?
Exactly. We're looking at a system that is deliberately designed to prevent you from solving a problem someone else has already solved. Modern development is all about integration, not isolation.
Okay, let's unpack this, because before we can just start pulling brilliant code down from the global internet, we kind of need to understand how Python handles its own internal toolbox.
Oh, yeah.
Like, when you install Python on your computer, you aren't just getting the language itself. You're getting this standard library of what the notes call modules.
Right, modules. You can think of modules as these discrete, isolated namespaces.
Okay.
They're essentially pre-written Python files. They get bundled with your installation, but they just sort of dormant.
They're asleep.
Basically, yeah.
Yeah.
Python doesn't load them into memory automatically because, if it loaded every single built-in tool at startup, your program would just eat massive amounts of RAM.
Oh, sure.
It would take forever to boot.
Yeah.
So you have to explicitly tell the interpreter to bind that specific module to your current working environment.
Right. And you do that with the import command.
You do.
But there's a nuance here that the notes mention. They bring up both import and from.
Yeah, the distinction there is important.
Right, because if we use the classic, import random, we're grabbing the whole namespace.
Exactly.
So we have to type random.choice or random.randint to tell Python exactly which toolkit we're pulling the function from. But if we use from random import choice, we're extracting just that single tool and dropping it right onto our local workbench.
Yeah, and that distinction is super vital for memory management and avoiding namespace collisions.
Namespace collisions.
Yeah, if you're building a massive application, you really don't want to import an entire heavy module if you literally only need one math function.
That makes sense. It's like having a library card for a toolshed.
Toolshed, right.
Like, you don't need to build a saw from scratch. You just check it out when you need it.
Exactly.
But looking at the random module specifically, I feel like it highlights why we rely on these tools so much.
Oh, for sure. Because generating true randomness computationally is incredibly difficult.
Because computers are just inherently deterministic machines.
Right.
Right. They only do exactly what you tell them to do.
Right. They don't do random. So when you use random.randint to get a number between 2 points.
Or like random.shuffle to reorder a list.
Yeah, exactly. You're not actually generating true randomness.
Oh, really?
No, you're triggering a complex mathematical algorithm. It's called a pseudo-random number generator.
Ah, pseudo-random.
Right. It uses a starting seed to produce a sequence of numbers that simply mimics randomness.
I see.
Because writing a uniform distribution algorithm that doesn't inadvertently, skew the probabilities is really hard mathematics.
And the core developers already did the math.
Exactly. So you don't have to.
But I've got a practical pushback here.
Oh, okay. Let's hear it.
The notes heavily emphasize looking up the documentation for these modules.
Yes, they do.
Like, they want you going to docs.python.org/3/library/random.html to figure out that random.choice actually requires a sequence. But in the age of AI coding assistants, Copilot, ChatGPT is digging through official documentation, actually becoming kind of an obsolete skill.
Oh, absolutely not.
Really? Why not just let the AI write the import statement and guess the parameters?
Because that is a dangerous trap. And it's exactly why reading the official docs remains a mandatory engineering skill.
Huh.
AI models hallucinate. They operate on probabilistic text generation, which means they frequently invent functions that sound completely plausible.
That don't actually exist.
Right. They don't exist in the underlying C code of the Python interpreter.
Oh, wow.
Yeah, the official documentation is the literal contract of the language.
Right.
It defines the exact input parameters, the big O time
Yeah.
complexity of the function, the specific memory types it returns.
Okay, so if you're using, say, the statistics module to calculate a median,
Yeah, good example.
and you rely on an AI's hallucinated parameter.
You might silently corrupt your entire data pipeline. The docs are the ground truth, period.
That makes a lot of sense. So, okay, we figured out how to pull in complex math and internal logic.
Right.
But a script running in isolation isn't really all that useful.
No, not usually.
Eventually, you hit this boundary where your internal program needs to talk to the external operating system that's running it.
Yeah.
So how do we get live data into a script at the exact moment we execute it?
So this is where we cross the boundary. We go from the Python runtime out to the operating system using the sys module.
The sys module.
Right. Found at docs.python.org/3/library/sys.html.
And specifically, we use a list variable inside it called sys.rg.
Sys.rgv. Okay, the notes show an example of running a program from the command line, like typing python hello.py followed by some extra words.
From a pure mechanism standpoint, what's actually happening when I hit enter there? Like, how does a word typed in a Mac or Windows terminal end up inside my Python variables?
Well, when you execute that command, the operating system parses everything you typed into an array of individual text strings,
Okay.
separated by spaces. The OS then hands that array directly to the C-level executable that actually runs Python.
Oh, I see.
And then the sys module intercepts that raw C array and translates it into a standard Python list, which is sys.argv.
So sys.rgv bracket 0 is always the name of your script.
Exactly, hello.py.
And sys.rgv bracket 1, 2, and so on are the actual arguments you passed in?
You got it.
It's kind of like sys.rgv is like shouting instructions to a chef right as they walk into the kitchen.
I love that analogy.
You know, rather than waiting for them to start cooking to tell them what you want.
Right, you just hand them a whole order up front.
But wait, this introduces a massive vulnerability, doesn't it?
It definitely can.
Like, if my code is hardwired to look at sys.rgv bracket 1 because it expects a file name and the user just forgets to type it and hits enter, what happens? Do we get a kitchen fire?
Yes, essentially. The notes mention an index error.
Right.
At a fundamental hardware level, trying to read an item in a list that doesn't exist is a memory violation.
A memory violation.
Yeah, you're asking the CPU to read an address in memory that just hasn't been allocated to that array.
Wow.
In lower-level languages like C, this causes a catastrophic segmentation fault.
Oh, yikes.
The whole program just crashes violently. Now, Python is safer. It intercepts that memory violation and raises an index error.
But an unhandled exception still stops your program dead in its tracks.
It does. It crashes the kitchen, as you said.
Which is just terrible user experience. You don't want the program vomiting a traceback error just because someone forgot one parameter.
Exactly. And that's why the sys module also provides sys.exit.
Oh, right.
A robust script will check the length of sys.argv before it does anything else. If the list is too short, the script prints a human-readable instruction on how to actually use the program, and then it calls sys.exit.
So it gracefully closes down.
Right. It sends a specific termination signal back to the operating system, closing the process gracefully rather than just letting the interpreter burn down.
And what if they pass too many arguments? The notes mention using slices for that.
Yeah. Slicing is a super useful memory manipulation technique.
How so?
Well, if a user passes 5 arguments, but you only care about everything after the script name, you can use a slice, like sys.rgv bracket 1:.
Right, pulling from index 1 onwards.
Exactly. Under the hood, Python actually allocates a brand new list in memory containing only that subset of data.
Oh, that's clean.
Yeah, it allows you to iterate over it cleanly without accidentally processing the name of the script itself as if it were data.
Okay, so we've bridged the gap to the OS, and we know how to handle user errors gracefully. But eventually you're going to hit a wall where the built-in standard library just isn't enough.
Inevitably, yeah.
Like, what happens when you need to do something highly specific? Process an audio file, run machine learning, and the core developers just didn't build a tool for it.
Well, then we have to leave the local environment entirely.
Right.
We tap into the global ecosystem.
Right.
The Python Package Index or PyPI.
Here's where it gets really interesting.
Yes.
PyPI, which is located at pipey.org, is this massive global repository of third-party packages.
It's huge.
And to get them onto your machine, you use this command line utility called pip.
pip, exactly.
But, okay, I have a serious bone to pick with the source material here.
Uh-oh.
PyPI hosts the infrastructure for the modern web, right?
Yes.
Advanced neural networks, data science tools that literally map the human genome.
All true.
And the prime example the notes give us for installing third-party software is a package called Cowsay.
Oh, Cowsay.
Yeah, located at pipa.org/project/Cowsay. It's a tool that draws a talking otter cow in the terminal.
It is indeed.
Why on earth is this our introduction to this profound global package ecosystem?
Well, what's fascinating here is that while it definitely seems like a joke,
It totally does.
using Cowsay is actually a brilliant pedagogical strategy for testing end-to-end pipeline verification.
Wait, pipeline verification for a cow?
Hear me out. When you type pip install Cowsay, a massive chain of events has to execute perfectly.
Okay.
Your terminal has to resolve the pip executable in your system's path variables. Pip has to open a secure network connection to the PyPI servers.
Right.
It has to resolve the metadata for the Cowsay package, check if your current Python version is compatible, download the correct files, and write them into your local site packages directory.
With the correct read and write permissions.
Exactly.
Ah, I see. So if you try to test that pipeline by installing a massive library like TensorFlow or Pandas,
And it fails.
you don't know why it failed.
Exactly. You don't know if it was a network error, a C compiler issue, a version conflict, or just a missing dependency.
Right. There are too many variables.
Precisely.
Yeah.
Cowsay has virtually zero dependencies and takes a fraction of a second to download. If you can pip install Cowsay, import it, and make a digital cow talk on your screen.
You've definitively proven that your local Python environment is successfully and securely tethered to the global PyPI registry.
Exactly. It's a lightweight sanity check wrapped in an old-school hacker joke.
Wow, okay. That completely reframes it for me. It's basically a diagnostic tool.
It really is.
But let's look at the mechanism of pip itself. It's not just downloading a simple zip file, is it?
Oh, no.
Because packages often require other packages to run.
Yeah, pip is a highly complex dependency resolver.
Dependency resolver.
Right. When you ask it for a package, it reads a manifest file. If package A requires package B and package B requires version 2.0 of package C,
They have to track all that down.
pip traverses that entire dependency tree. It calculates the compatible versions of every single required library and installs them in the correct order.
That's wild.
Yeah, it resolves what developers actually call dependency hell.
Ah.
It allows you to seamlessly integrate massive frameworks into your project with literally a single command.
That is incredibly powerful.
It is.
So pip brings static, third-party code into our local environment, but modern applications rarely rely entirely on just local static code.
No, they don't.
What if our script needs dynamic, live data, like fetching current stock prices or pulling the latest weather satellite telemetry?
Well, that requires communicating across the internet dynamically at runtime,
Right.
which brings us to APIs and the request library.
The notes unpack APIs, which stands for Application Programming Interfaces.
Yes.
And I kind of want to ditch the cliche analogy of an API being like a waiter at a restaurant.
Oh, I'm glad.
It just doesn't capture the scale of what's actually happening. To me, APIs are more like the invention of standardized shipping containers in the logistics industry.
Oh, that is a much more accurate framework.
Because think about it, before shipping containers, every port handled cargo differently.
Right.
You had barrels, crates, loose items. It was absolute chaos to load and unload. And before APIs, servers sent data in wildly different formats, but an API acts as a standardized port. The requests library, which you have to download via pip, by the way, from docs.pythonrequests.org, that library is the cargo ship that sails to that port.
It is. It sends a highly standardized HTTP request over the network.
Exactly.
And this raises an important question.
Okay.
If the API is the standardized port, what is the shipping container itself?
Oh, the format of the data.
Right. How is the actual data packaged so that any programming language can read it?
Well, the notes highlight JSON for this, which stands for JavaScript Object Notation.
Right. Think about the sheer complexity of the modern internet. A database might be written in C++, the serve logic in Java, and your script is running in Python.
They all organize memory completely differently.
Exactly. You can't just send a raw Python dictionary over an Ethernet cable.
The Java server would have no idea how to read those memory addresses.
It would be gibberish. JSON solves this by flattening complex data into a simple universal string of text characters.
A text string.
Yeah, it's a lightweight syntax of just brackets and braces that everyone agrees on.
So if JSON is just a text string, why does Python have a dedicated built-in JSON module?
Ah,
Found at docs.python.org/3/library/json.html. Like, why can't we just treat it like any other string of text?
because of the mechanism of deserialization.
Deserialization, yeah.
Yes, a string of text is mostly useless to a CPU if you want to perform rapid logic on it.
Oh, I see.
You can't easily query a flat string to find the value of a specific key without writing really complex, error-prone text parsing loops.
That sounds like a nightmare.
It is. So the JSON module's job is to take that universal text string and dynamically allocate memory to construct native Python dictionaries and lists out of it.
Oh, wow.
It translates the raw text into a hash data structure that your code can query in constant big O of one time.
It bridges the gap.
Exactly, between universal text communication and optimized local memory.
It's literally the translator that turns the shipping container back into usable materials.
Perfectly said.
Okay. We have covered an immense architectural stack here.
We really have.
We've pulled isolated tools from the built-in standard library.
Yep.
We've used sys to command the operating system. We've used pip to navigate the dependency trees of PyPI. And we've used requests and JSON to parse live strings of data from global APIs.
It's a lot.
It is. With all of these files, modules, and network calls interacting, how does Python keep track of who is actually driving the car?
That is the big question.
If every file has code in it, what stops them all from just trying to execute simultaneously when they get imported?
This is a critical point of failure in large systems. And it brings us to the final concept in the notes, the hidden infrastructure of the dunder name variable.
Dunder name. So what does this all mean? The notes show this oddly formatted variable with double underscores on each side.
Right, which developers usually pronounce as dunder name.
Okay, so I visualize dunder name as sort of a VIP badge at a software conference.
Oh, I like that.
Every single Python file gets handed one of these badges the exact moment it gets loaded into memory.
Yes, the C-level interpreter assigns that badge right during the initialization phase.
Right. Now, if I am the file that you actually executed from the terminal, like if you typed python hello.py...
You're the main event.
Exactly. The interpreter looks at me, realizes I'm the star of the show, and writes the specific string quote underscore underscore main underscore underscore quote on my VIP badge. But if I'm just a helpful file, like the random module, or our good friend Kause.
Just a guest.
Right. I was merely imported into the script as a guest. The interpreter writes my actual file name on my badge instead.
That's precisely the mechanism. And if we connect this to the bigger picture, it solves a huge fundamental architectural problem.
Which is?
Often a developer writes a Python file containing a bunch of useful math functions, but they also put some test code at the bottom of the file to make sure those functions actually work.
Oh, right. But if I import their file to use one of those math functions, I definitely don't want all their test code to suddenly just run on my machine.
Exactly. And that's why you wrap the executable part of your code in an if statement checking that badge.
Ah.
You're right. If dunder name equals, quote, dunder main quote.
It's a control flow gate.
It is. When Python imports the file, the badge says the file name, not main.
So the gate stays closed.
The gate stays closed. The file quietly offers up its functions to the local namespace without executing its own logic.
But if you run that file directly...
The badge says main, the gate opens, and the internal code executes.
That is so elegant.
It's how Python meticulously isolates executable scripts from reusable libraries, even when they are technically the exact same file.
It's like self-awareness for code. It allows a file to know its own context within the broader system.
And context is everything when you're assembling complex digital architecture out of hundreds of discrete borrowed components.
Wow. Let's take a breath and just zoom out for a second.
Let's do it.
We started with the realization that writing code from absolute scratch is essentially an anti-pattern in modern development.
Very much so.
We learned how to manipulate our local namespace with modules. We bridged the gap to the OS with sys. We pulled down pre-built dependency trees from PyPI using pip. And we parsed standardized text from the living internet into local memory using requests and JSON.
It's quite the journey.
And underneath it all, the interpreter quietly manages the execution flow with the dunder name gate.
It really represents a massive leap in capability for a programmer.
Yeah.
You aren't just writing isolated logic anymore. You're orchestrating this global ecosystem of moving parts.
But I want to leave you listening with a final lingering thought to mull over.
Okay.
If modern programming is increasingly about using pip to grab someone else's algorithms,
Right.
and using APIs to grab someone else's data, at what point does a software engineer stop being a builder forging logic from scratch
Oh, that's a good question.
and become more of a director, just assembling the brilliant pieces of a decentralized global community into a new vision? Like, what does that shift mean for the future of digital creativity when the friction of building is entirely removed?
Man, that is the beautiful underlying tension at the absolute heart of modern software development.
Truly. Thank you for joining us on this deep dive. Keep questioning the mechanisms behind the tools you use. Keep exploring, and we will catch you next time.